This is an operating systems question based on CPU scheduling. We have three processes which arrive all at the same time, 0 units, with their CPU burst times of 16, 20, and 10 milliseconds respectively. The scheduler has prior knowledge about the length of the CPU burst, which means it already knows their burst times as 16, 20, and 10. So in this case, the minimum achievable average waiting time for these three processes in a non-preemptive scheduler will be how much? So in this scenario, they have not given us which scheduling algorithm has to be used. We have to decide that ourselves. Based upon these two facts, that the algorithm has to be non-preemptive and CPU has the prior knowledge of their burst times. So in that scenario, what are the possible algorithms we can look for? FCFS can be used, but all of them are having the same burst times. They will be executed in the same order. It is a valid candidate. We can check for that. Then next comes shortest job first. That is also possible. It is non-preemptive, and with the given burst times, they can be executed in the order of 10, 16, and then 20. So this is also a valid candidate to be checked. Apart from that, if we go for round robin, it will become preemptive. SRTF again preemptive. So they will not be possible for the scenario. We'll just check for FCFS and SJF, that which of them gives the minimum achievable waiting times. So just trace out their Gantt charts and check out. For FCFS, there is another problem here, that they have not clearly mentioned that this process has arrived first followed by these two. They have just said that all of them arrived at the same time. So if we go to assume that they might have arrived in this given order 16, 20, and 10, then we can check for that. Otherwise, they have not clearly mentioned what was their order of arrival. Still, let's see what do we get. Let us call the processes as A, B, and C. So first, this would be the table. Arrival time is 0 for all, burst time, completion time, turnaround time, and the waiting time. Okay, so the burst times is 16, 20, and 10 for the processes A, B, C. They will be completed in the same order. This is timeline 0 up to 16 it will execute. Then from 16 to 16 plus 20 means 36. B will execute. Then C will execute up to 46. So their completion times would be 16, 36, and 46. Turnaround time will be given as completion time minus arrival time. Arrival time is 0 for all. So turnaround time will be 16, 36, and 46 respectively. Now this burst time is given as turnaround time minus of waiting time. Sorry, the turnaround time minus of burst time. That gives us waiting time. So that will be 16 minus 16, 0. 36 minus 20, 16. Which means the process B arrived at time t equal to 0 and it executed from 20 for 20 seconds from 16 till 36, which means it waited for this particular duration of 16. Similarly, process C that waited from 0 till 36. 46 minus 10, 36. So this is the time it waited for. So the sum of their burst times is 36 plus 16, which is 52. And if we take out the average, 52 by 3, it would be something about 17. So now let us check for the shortest job first if it gives the better performance. So for that, we'll again do the same thing, trace out the Gantt chart and see what is the waiting time we get for that. And we'll also note down the average waiting time which we got for FCFS, which was about 17. Now for the shortest job first, this is the burst time for the processes A, B, C, 16, 20, and 10, completion time, turnaround time, and waiting time. So the first process to be executed now will be C because it is having the smallest burst time. So it will execute from 0 till 10. Next will be A from 10 till 10 plus 16 means 26. Then finally B from 26 to 46. Their completion times will be A completed at 26, B at 46 and C at 10. Their turnaround times will also be same because their arrival time is 0. Now waiting time will be turnaround time minus burst time. So for A it is 10, for B it is 46 minus 20 means 26, and here it is 0. So the sum is 36. That divided by 3 gives us 12. So this is definitely lesser than for FCFS. Hence the SJF scheduling algorithm will give us the minimum achievable average waiting time for these 3 processes, and that time is 12 milliseconds. So the answer for this question would be 12.